So find the gradient of the curve with equation y is equal to x squared take 1 over x squared plus 2 at the point where x equals 2. So this has given us just the exact amount of information that we need, nothing extra in there thrown in to throw us off, or equally it's not sort of an applied situation, so it's being very straightforward with us. So we've got essentially a u over v situation where our u is equal to x squared take 1 and our v is equal to, in fact let's do our v over here like usual, v is equal to x squared plus 2. U dash is going to be 2x and v dash is also going to be 2x. So our dy by dx, our differential of this, is going to be u dash v take v dash u all over v squared, which is going to give me u dash 2x times by v, which is this thing times by this, which is x squared plus 2, take v dash times by my u, so 2x times x squared, take 1 all over v squared, which is going to be x squared plus 2 all squared. Now, at this point, I'd usually be trying to look to simplify that, but really the questions just ask me the curve for the equation, like the gradient of this point at the point where x is equal to 2. So what I can actually do here, we essentially have f dash of x, or dy by dx, and I'm just going to sub in x equals 2 into this whole thing above. Now, I could simplify before doing that, but it doesn't make any difference. It should come out the same as long as I'm careful. So I'm going to get 2 times by 2, and then 2 squared plus 2, take 2 times by 2 times 2 squared, take 1 all over 2 squared plus 2 all squared. So that looks very messy, but I can quickly work through this as long as I pay attention to my brackets. 4 plus 2, take 4 times 4, take 1 all over 4 plus 2 all squared, which is going to give me 4 times 6, this is 24, take away 4 times 3, which is 12, all over 36, which is going to give me 24 take 12, which is 12 over 36, which cancels to 1/3. Now, considering it didn't ask me for anything more than the gradient, I have found the gradient here, so I can stop there with my answer being 1/3. So, next question on this was question 3. So the function has this form, and we're given these two pieces of information. So what I'm going to start with straight away, considering we've been given this hint here, that f dash 1 is equal to 0. So I'm going to find f dash, I'm going to differentiate f of x. So f dash of x, just differentiating this term first, this is going to be 2ax, and then differentiating this, this is just going to be b. Now I'm told that f dash of 1 is equal to 0. So realistically, I can just sub in 1 into this equation. So f dash of 1 is actually going to be 2a times 1 plus b. So I actually know that this is equal to 0. So that means that 2a plus b is equal to 0. The other piece of information I've got, so I've kind of used up this piece of information now. The other piece of information I've got is f of 1, which is going to be a times 1 squared plus b times 1. This is equal to 6. So what I know is f of 1 is equal to 6. And this stuff on this side is just going to be equal to a plus b. So I've now got two simultaneous equations here. So I can do a bunch of different things with these, but I think the most simple thing I can do here is a bit of substitution. So I'm actually going to say, okay, well 6 take b is equal to a. And I'm going to grab this a, essentially, and put it into this equation. So wherever there was an a, so sub 6 take b equal a into 0 equals 2a plus b. So 0 is equal to 2. Now wherever there would be an a, I'm just going to write 6 take b plus b. And then I'm going to get 12 take 2b plus b. And then I'm going to get 0 is equal to 12 take b. So b is equal to 12. Then I can just substitute this b equaling 12 back into either of these equations really. In this case I'm just going to sub it into this one. So I'm going to get a is equal to 6 take away b, which is 6 take away 12. So a is equal to negative 6. So that's what I was asked for, a and b, values of a and b, and I'm done. So next bit, we've got a pretty obvious product rule going on here, and all it's asked us to do to start with is find f dash of x. So we've got our u is 2x and our v is over here. And so we've got u is equal to 2x, v is equal to log e 2 on 3x. Now our u dash is nice and easy, that's just 2. Our v dash, we've got to think a little bit. Now in truth, we can play around with our v first here, because actually this x being on the bottom isn't what we kind of want to see, and there is a little trick that we can use. So we can actually say v is equal to log e, and then in our bracket I'm actually going to change this to 3x on 2 to the negative 1. Now if you need to justify that in your head, you can have a good look over it, but then this negative 1, using the rules of logs, we can actually just pull out the front, so we get negative log e 3x on 2. And this is much easier for us to differentiate. So I'm actually going to use this as my v instead of what they've given me. So I'm just going to bring this back up here. Alright, so now I've just got to differentiate this thing. Now this is just going to be negative 1 on x when I differentiate it. And it's going to be easy to work with in general. So then I've got u dash v plus v dash u. So u dash v is going to be negative 2 log e 3x on 2, and then plus v dash times by u. Now adding that v dash times by u is going to give me negative 1 on x times by 2x. Now these x's are going to cancel, first thing that I notice, so this is going to become negative 2 take 2 log e 3x on 2. Alright, nice and easy. So for my second part of this, I just need to substitute in 1 into this, which I found before. So this was f dash of x. And now I just need to do f dash of 1. So I get negative 2 take 2 log e to the 3 times 1 on 2. And this will give me negative 2 take 2 log e to the 3 on 2. And there's no need for me to simplify or attempt any more than this. There we go. And we can move on to the next question. Alright, so this is asking for me to find the equation of the tangent of the curve. So equation of the tangent, I'm looking for something in the form of y equals mx plus c. Now we've got our equation here. So the first thing that I'm going to do is it said at the point where the gradient is negative 10. So the first thing I'm going to do is dy by dx. I'm just differentiating this up here. I'm going to get equals 8x take 2. Alright, now I've been asked for it at the point where the gradient is equal to negative 10. So this point will be when this is negative 10. So I've just got to find the x value at this point. So moving the negative 10, I add 10 to both sides. I'll get 0 is equal to, in fact, let's just add 2 to both sides. So I'm going to get negative 8 is equal to 8x. So I'm going to get x is equal to negative 1. dividing both sides by 8. So I want the equation of the tangent at this point. Now at that point, I need to find out a few things. So I already know from the question that the gradient is -10 at this point. This is going to tell me that's my m. So really all I'm looking for, the information that I need to gather from this guy, is what the c value is. Alright, so I need to find this out now. So the way that I'm going to do this is, I know that this is a point on my curve, so I need to substitute this back into this equation. Alright, and that's going to give me a y value. So if I've got y is equal to 4 times -1 squared, take 2 times -1 plus 3, this is going to actually give me 4, add 2, add 3. So this is going to give me 9. So this tells me that -1, 9, this is a point that's both on the curve and on the tangent. So this is on the curve and the tangent. Now, considering that it's on the tangent, that's the main thing that I need to know. So what I'm going to do is sub this point into y equals -10x plus c. So this tells me 9 is equal to -10 times -1 plus c, and this is going to allow me to find my c. So what I've got is 9 is equal to 10 plus c. So then I'm just going to take 10 from both sides, and I'll get -1 is equal to c. This tells me that the equation of my line is y is equal to -10x take 1. Alright, and I can move on to the last question. So this is really just saying, where is there a positive gradient? Alright, because this is our gradient of our function, and it's just asking for when it's greater than 0. So all I'm going to do is differentiate the function. I'll get 6x squared plus 6x take 36. Now, considering that I'm looking for when this is greater than 0, I want to know when 6x squared plus 6x take 36 is greater than 0, and for what values of x this occurs for. Well, the easiest way for me to do this is probably to have a bit of a sketch of the graph. And for me to sketch this graph, this thing here, I'm going to look for my intercept points. I'm going back into factorizing for this. So I've got this, and I want to know when this is greater than 0, so I've got 6x plus 3, x take 2. Alright, so looking at this, this tells me that I've got intercept points at -3, and this tells me I'm going to intercept +2. So I don't know much else about this graph. I don't really need to know much else other than which way it's going. Is it going like this, or is it going like this? And having a look, we can see that this is going to be this is a positive graph. So we're going to get a nice smiley face. I'm going to do a better job of drawing through these points. And then all I need to look for is, when is this greater than 0? So when is this, considering that this is f dash of x essentially on this axis, and this is x going across on this axis. Well, it's greater than 0. It's greater than 0 all this time, and then all of a sudden it's not. It goes through a bad spell, and it comes back out over here. So actually, the times when it's greater than 0 is if x is less than -3, and if x is greater than 2. Okay, so I could write this mathematically a little bit better, because I could actually write, if x is an element of -∞ to -3, unioned with 2 to infinity. And that's sufficient for my answer.